Good morning, everybody. All right, so we're going to do examples for 7.3, 7.4, and 7.5. It sounds like a lot, but they're really all basically the same. You have to remember, what are we trying to do in this chapter? This chapter is solving systems of linear equations. That means, basically, where do the two lines that they give you the equations for intersect? 95% of the time, they're going to intersect at a point, okay, 2 comma 3 or negative 4 comma 1. That's your answer you're going to get. So you're going to have three choices for an answer. You're going to give me an ordered pair, x comma y, or the variables are going to eliminate, and you're going to get a true statement. And we know that when we get a true statement, the answer is all real numbers. Or the variables are going to be eliminated, and you're going to get a false statement, 0 equals 8. Well, if it's false, then there is no solution. So that means they don't intersect. Think about it. What kind of lines don't intersect? Parallel lines. So you're going to get the answer of no solution when you have parallel lines. You're going to get the answer of all real numbers when it's the same line. It might not look the same because line is going to be the multiple of the other, meaning you took a number and multiplied everything in the top equation by a number to get the other equation. All right, for the 7.3, we're going to get ordered pairs for answers. Okay, these lines are going to intersect, and they're going to intersect at a given point. In 7.3 and in 7.4, we are solving by elimination. And 7.5, what do we want to do? We want to eliminate, get rid of one of the variables. So the first thing you're going to do is you're going to look at the two equations, and you're going to see, is there a variable in both equations that if you added them, it would cancel out? So if you look at number 1, for example, you see 3x and negative 3x. If you add those two terms, they're going to go to 0. That's what you want to happen. You want one of the variables to be eliminated. It doesn't matter which one. We just want one of them to be eliminated. So one we want to be a positive and one we want to be a negative. So first thing we ask, which variable should we get rid of? Number 1, we should get rid of the x. Then it says to add the equations. So we're going to take and we're going to add the equations. So when we add these equations, we get 3x minus 3x is 0. 4y plus 5y is 9y. And 8 plus 10 is 18. Now we have to solve for y. So if we divide by 9, we get y equals 2. Now we know what y is. Again, remember, we're looking for an ordered pair. So we still need to find x. So we know y equals 2. We go up and we pick an equation. Doesn't matter which one you pick. I'm going to pick the top one. Plus 4y equals 8. And now we're going to substitute. Okay. So we're going to take the y equals 2 and plug it into the equation. This is a plus. There we go. And this is a 4. All right. So we get 3x plus 4y, but instead of the y, we put our 2 equals 8. So we get 3x plus 8 equals 8. Then we subtract 8. and we get 3x equals 0. So now, divide by 3, and x equals 0. So now we know what x is. So we're going to go back up, and we're going to put our 0 in for x. Okay? You can check this. Check 0, comma 2. Okay? Put it in the equations. 3 times 0 plus 4 times 2 equals 8. 0 plus 8 equals 8. Yes, it does. Put it in the second equation. Negative 3 times 0 plus 5 times 2 equals 10. 0 plus 10 equals 10. Yes, it does. All right, so now we've checked. This, therefore, is our answer, 0, comma 2. Where do these two lines intersect? They intersect at 0, comma 2. All right, so now let's try the second one. Notice the second equation. Look at the variables, look at their coefficients. The very first thing we have to do is decide which variable to eliminate. Well, if you look, the coefficients of y are the same, 6 and 6. However, if you add 6 plus 6, you do not get 0, you get 12. You need the variables to be opposites of one another. Okay? I don't know how to erase that. That's just weird. But anyways, so go over here. You want 6y and you want a negative 6y. Well, if you want a negative 6y, then you're going to have to multiply one of those equations by negative 1. So if we take and we multiply this top equation by negative 1, we get negative 5x minus 6y, or plus negative 6y, equals negative 4. So really you're just taking the opposite of everything in that first equation. Now copy over the second equation. Now look at y. Now when we add negative 6 and positive 6, it will eliminate. So when I add negative 5 and 7x, I get 2x. The y's cancel, and negative 4 and 8 is positive 4. Divide both sides by 2, and x equals 2. So now I know x equals 2. I need to find y. Okay? All right? So this one over here, I could have kept this as 0, comma 2, correct? 0, comma 2. All right, so now I have to find y. So again, I'm going to take my x equals 2, and I'm going to choose one of the equations. So if we take 5x plus 6y equals 4, and substitute in, I get 5 times 2 plus 6y equals 4. 10 plus 6y equals 4. Solve for y. Subtract 10 from both sides, and 6y equals negative 6. What do we do now? Now we divide by 6, and y equals negative 1. So now we know the value of x, and we know the value of y. So that gives us our ordered pair, or our solution. So our solution is 2, negative 1. When x is 2, y is negative 1. This is where these two lines are going to intersect if you were to graph them on a plane. All right? All right, let's do number 3. Well, 3 looks a little different. 3 looks a little different. Notice that second equation. That second equation, all right, does not have, is not written, I should say, in standard form. So the first thing you have to do is write the equation in standard form. What's standard form? Remember, ax plus by equals c. You want the x and the y on the same side. So if you have 3y equals negative 7x plus 30, then you're going to add 7x to both sides. Okay, I'm going to erase some of this so it doesn't look confusing. There we go. All right, so when we do that, what do we get? We get, let's go scroll up a little bit here. Whoops, scrolled up too much. There we go. We get 7x plus 3y equals 30. So now we have two equations in the same format. We have 9x minus 3y equals 18, and we have 7x plus 3y equals 30. Now add. 9 and 7 is 16, 3y and negative 3y is 0, and 30 and 18 is 48. If we divide by 16, x equals 3. Now we know x equals 3. Now, what do we have to find then? We have to find y. So now you're going to take x equals 3, and you're going to pick an equation. Again, it doesn't matter which equation you pick. So let's do 9x minus 3y equals 18. Okay. If we do that, substitute the 3 in, you get 9 times 3 minus 3y equals 18. That's 27 minus 3y equals 18. You're going to subtract 27 from both sides, and you're going to get negative 3y equals negative 9. Then you're going to divide by negative 3, and y equals 3. So your ordered pair, your point of intersection, your solution is 3, 3. All right, so that's the first type of problem you're going to get. You're going to get problems that have the same or opposite coefficients. So that's the easiest type you're going to have. If you have the same coefficients or opposite coefficients, you can see pretty much what you have to get rid of. You just have to eliminate that variable. In 7.4, it's not going to be as easy to see. Okay, they're not going to be the same. So what do we have to do? We have to ask ourselves, how can we make them the same? How can we make them the same? Okay, so we can make them the same by multiplying every term in the equation by the same number. That's an equivalent equation, remember. Okay, so for example, let's look at number 1 in 7.4. You have 2x plus y equals negative 9. You have 4x plus 11y equals 9. Some of you are going to say, oh, if the x's both had a 4 and a negative 4, they would be eliminated. Some of you are going to say, oh, if the first y was negative 11, then the y's would be eliminated. It doesn't matter which one you choose to eliminate. It will work both ways. Okay? So if we decide to choose x, we choose x, then we need both of those. We need one of them to be negative 4 and we need one of them to be 4. Well, we already have the 4. So we have to say, what do we have to multiply the first equation by to get negative 4? We have to multiply by negative 2. Okay, so we're going to take and we're going to multiply that first equation by negative 2. So negative 2 times 2x plus y equals negative 9. What do we get? We get negative 4x plus negative 2y equals positive 18. Don't forget a negative times a negative. So now we're going to just put the other equation right under it. And now we see that those x's are going to cancel when we add the two equations. So we're going to add those two equations. The 4's cancel. Negative 2 plus 11 is 9y. And 18 plus 9 is 27. Divide by 9. And y equals 3. Now we have to solve for x because we have y, but we don't have x. So we know y, we know y equals 3. We choose a variable, an equation, I'm sorry, equals negative 9. And again, it doesn't matter which one you choose, and you substitute. 2x plus 3 equals negative 9. Subtract 3, and 2x equals negative 12. Divide by 2, and x equals negative 6. So what's our solution? Negative 6, comma 3. That's our solution. All right, let's do another one. Let's erase some of this. There must be an easier way, do you think? Probably, I just don't know it. Okay. Example 3. Look at example 3. What are we trying to find? We're trying to find an ordered pair. What do we need to know? We need to know x and y. Well, what do we already know? We already know x equals 0. We don't have to find it. It's done for us. So now all we have to do is find y. So we're going to take 7x plus 4y equals -8 and substitute. 7 times 0 plus 4y equals -8. Whoops, we didn't need that really. Okay, just trying to scroll. There we go. So now what do we have? 0 plus 4y equals -8. Let's go back over. Whoops. There we go. Let's go back over here and finish up. So 4y equals -8. Divide by 4, and y equals -2. So our ordered pair, 0, -2. Again, what does that mean? It means if you took and graphed these two lines on a plane, that's their point of it. That's where they would intersect. That's where they would intersect at 0, -2. Okay? All right, last one for this section. Last one for this section. So what you should be doing right now is looking at the two equations and saying, which variable should I eliminate? And what do I have to do to eliminate it? Which variable should I eliminate? And what do I have to do to eliminate it? Well, I'm looking and I see that my y's could be eliminated if I added them if there was a -2 in front of the top y. So what does that mean? That means all I need to do is multiply this equation by -2. So if I multiply that by -2, for some of you it might be better if I put it over here. So let me do that instead of over here. So then what are we going to do? We're going to distribute. So -2 times 3x is -6x. -2 times -y is positive. Oops, so I don't want to multiply by -2. Oh, see the careless mistake we could make? It's already negative, so I don't want to multiply by -2. I want to multiply by +2. So let's try that again. So if we multiply by +2, 2 times 3 is 6x. 2 times -y is -2y. And 2 times 13 is 26. Now I'm going to copy that second equation. And now I'm going to add. So we have 8x, y's cancel out, equals 26 minus 10 is 16. Divide both sides by 8, and x equals 2. Now I have x equals 2. I need to find y. I need to find y. So I'm going to use that second equation. 2x plus 2y equals -10. You could use the top one. So 2 times 2 plus 2y equals -10. That's 4 plus 2y equals negative 10. Now what? So if we have 4 plus 2y equals negative 10, solve for y, so subtract 4, and I get 2y equals negative 14. Divide by 2, and y equals negative 7. So where do these two lines intersect? At x equals 2 and y equals negative 7. I hope everybody's getting this. Again, remember, what are we trying to find? We're trying to find an ordered pair. So we need an x and we need a y. Okay, we need an x and we need a y. What's it called? Solving systems by elimination. So what are we doing? We're eliminating a variable. So you have to choose a variable to eliminate and then solve for that other variable and then substitute and find the value of the other variable. So what are we doing? We're just solving equations, something we've done since chapter 3. Okay, so this is not really much, it's new in the sense that we have to figure out what variable to eliminate, but then we're solving, which is not new. So our answer was 2, negative 7 there. All right, 7.5. 7.5 is the same as that's not working. Is the same as 7.3 and 7.4 combined. But let's see what's going to happen here. Watch what happens when we go to solve. All right, first we're going to choose a variable to eliminate. Well, the x's have the same number and the y's have the same number. So it doesn't matter which one we choose. But what do we notice? They're the same sign. So we need to have opposite signs. One needs to be like if we choose x, one needs to be 2x and one needs to be negative 2x. So what do I have to do? I have to multiply one of those equations by negative 1, the top one or the bottom one. It doesn't matter. So if I multiply that bottom one by negative 1, I get negative 2x plus 3y, because there's two negatives there, equals, again, negative 1 times negative 4, positive 4. Now I have my equation. Take my first equation, write it right underneath. And then, let's see, add. Negative 2 plus 2, 0. Positive 3 minus 3, 0, equals 10. Oh, ding, ding, ding. What happens when the variables are eliminated? We have a choice, all real numbers or no solution. Does 0 equal 10? No, it does not. Okay, so because it doesn't equal negative 10, there are no solutions. All right, so this isn't a new concept. We've had this many times before. When the variables are eliminated, you have to decide, is it a true statement? If it is, then it's all real numbers. If it's a false statement, then it's no solution. So let's look at this one. Whoops, I was trying to erase that. Number 2. All right, first thing we have to do is get the x's and the y's on the same side of the equation. So we're going to subtract 2x from both sides. So that's going to be negative 2x plus y equals -4. Then you have 4x minus 2y equals 8. That's the top equation. I'm just rewriting it underneath so that I have my two equations that I can solve. So now what do we want to do? We have to eliminate a variable. So we have to choose which variable do we want to eliminate. Well, we can eliminate x's or y's. But I'm looking at the y's and I see a -2 in front of the y there. So maybe if this one had a +2, then they would be opposites. So let's multiply the top one by 2. You're going to get -4x plus 2y equals 4. Equals 8. I'm sorry. No, equals 4. No, equals 8. What am I doing? Oh my gosh, I'm so confused. Let me see. 4x, -4x plus 2y equals 8. -4x plus 2y equals -8. Sorry, guys. Not quite sure here what I'm doing. Okay, plus 2y equals -8. Okay, and this is the top equation here. Okay, -4. I copied down the right one. Sorry about that. So now you have 4x minus 4x, 0. -2y plus 2y is 0. And 8 minus 8 is 0. So 0 equals 0. That's a true statement. So because that's a true statement, it's going to be all real numbers. Because no matter what number you put in this equation, it's always going to work. So all real numbers. And what is that? It's my funny little R, remember. All real numbers. Reals. So those are the two solutions you can get. Okay? All right? I hope this helps. Kind of